Hi everyone. Today we are kicking off the first session in our DevConnect series, focused on the ODA MCAD, Open Infrastructure for Mechanical CAD Interoperability. Engineers from the MCAD team are here with us and ready to answer your questions. We'll introduce the project, review its key capabilities, highlight recent updates, and share what's next, followed by a live Q&A session. Well, so why does this matter? It's not about the number of formats. It's that each format is its own world, with its own kernel, data model, and licensing. As a result, companies must either pay for multiple CAD systems or risk data loss when converting. Every new format means new integration, new SDKs, and ongoing maintenance. This turns into a business problem. Costs grow with every format, leading to fragmented tool chains, vendor lock-in, and rising complexity. People often think the problem is about file formats. In reality, it runs much deeper. Every CAD system is built on its own geometric kernel, and these kernels are fundamentally different. Granite, used in Creo, uses tolerance-based modeling with aggressive tolerance propagation. Parasolid, used in NX SolidWorks, has strict tolerance control and a well-defined BREP standard. CGM, used in CATIA, is an entirely separate world with non-manifold topology and multi-representation geometry. ACES, used as shape geometry in Inventor, is yet another kernel with its own math feature trees and that are not portable. Parametric relations and regeneration logic are all format specific. They just convert everything to step approach inevitably results in data loss. This is the real industry map. CAD formats differ not so much by file structure as by geometric kernels and feature models. This is the main factor determining the complexity of interoperability. For kernel ecosystems, Parasolid, the most widespread kernel in the industry used by NX, SolidWorks, SolidEdge, and Onshape. This means conversion between these systems is relatively straightforward since they share the same geometric foundation. CGM from the Solid systems, the closed world of CATIA and 3D experience. Fully proprietary, no external SDK, no public documentation. The topology model supports non-manifold geometry and multi-representation curves. Granite from PTC. Tightly integrated into Creo, not a separate product oriented toward feature regeneration, tolerance-based modeling, and geometry healing. ACES, or Shape Manager in Autodesk, powers Inventor or AutoCAD and BricsCAD, and Shape Manager is Autodesk fork of ACES. The full CAD data stack goes from application to feature model to geometry kernel to BREPs and to mesh. Understanding this map is key to understanding what ODA MCAD is building. We group MCAD formats by their degree of openness. This classification helps understand the different challenges and approaches for each group. The first one is proprietary formats. SolidWorks, CATIA, NX, Creo, SolidEdge. These are closed binary formats with no public specification. They contain the richest data, full features tree, BREP geometry, PMI, assemblies, and parametric relationships. Supporting them requires either reverse engineering or vendor-provided APIs. Vendor-governed open formats. GT, Rhino 3DM, KIF. An intermediate category. GT has an open specification published as ISO but is governed by Siemens. 3DM has a fully open source SDK called OpenNURBS maintained by McNeil. KIF is a quality information standard. These formats provide geometry and metadata but typically not full parametric models. And finally, open standards, STEP and IGES. ISO or industry standards with published specification, they provide universal exchange capabilities, but inevitably lose format-specific data like feature trees, parametric relations, and regeneration logic. ODA provides coverage across all three groups: proprietary, vendor-governed open, and open standards through a single unified platform. Well, one API, every format, full fidelity. This slide defines our core promise. One API, full fidelity, proven by working code. Breadth. We cover all major proprietary formats plus open standards. This year we are adding CATIA, NX, and Creo. This closes the last gap and provides coverage of all major MCAD systems through a single platform. Depth. This is not a simplified viewer. We provide native BREP access and full PMI for manufacturing workflow. Unity. We have two API levels. The common API provides a single interface where the same code works for SolidWorks, Inventor, Step, and every other format. But if you need one specific format, each SDK provides its own format-specific API with full access to native capabilities. SolidWorks configurations, sheet metal, design tables, everything that is specific to that format. Common API for breadth and format-specific API for depth. You choose what your project needs. Fidelity. A fundamental architectural decision. We do not convert data to an intermediate representation. You work with the same data the original CAD system works with. Zero loss at the intermediate stage. Well, here is today's agenda. I will cover common CAD API, highlight our progress with proprietary and open formats, and outline our plans for the year ahead. And I would like to start from MCAD API. MCAD Common API is an unified API that enables working with all formats we discussed and more. Supported formats include SolidWorks, Inventor, Step, IGES, PRC, KIF, OBJ, STL, and even external non-ODA toolkit format like 3DM. Integrating a new format doesn't require rewriting your application. You add a module and your existing code just works. One include one API call. Since Common API is designed for rapid solution development, even the list of supported formats and file extension is exposed through a dedicated class. This allows creating a file open dialog of code. What you get through one interface. And here what you an API. Across different formats, it gives you model hierarchy access, object properties, primary and alternative geometric representation, drawing model list and PMI objects, layers and styles, format-specific settings, exposed via specialized APIs suitable for UI generation. Now let's move to a demo where we'll open multiple formats in the ODA example application. Well, in this video, we demonstrate the capabilities of our unified MCAD Common API. which acts as a wrapper for different native SDKs and enables seamless work with a wide range of formats with a single environment. First, we loaded step file powered by ODA SDK. Now we see IGES model based on the IGES SDK and wrapped with the same CAD Common API class. For the key format, the hierarchy is more detailed. In addition to Maze 3D model, we see PMI visualization. Next is already GT format, binary format from a Siemens. What also we are going to see here the 3DM, the STL, a set of formats that are supported natively but via MCAD Common API. So this sample application is available in MCAD Common API release package. In addition to integration with visualization SDK is supported through MCAD to visualize module, which is also provided as an example. Well, other principle is native API for every format. This is architectural principle that sets us apart from competitors. We do not force data into a single intermediate format. Each format lives in its own native database. A SolidWorks file stays as a SolidWorks database, Inventor as an Inventor database. This preserves the full accuracy of the original data geometry, topology, parametrics. Each format-specific API exposes everything that exists in the native data. SolidWorks configurations, display states, sheet metal, design tables, cut lists. Inventor document properties, assembly constraints, step AP242 PMI semantics, supplemental geometry, digital signatures, GT, load management, tessellation levels. MCAD Common API provides unified model hierarchy access, object properties, primary and alternative geometric representation, drawings, model list, and PMI objects layer and styles. Format-specific settings are exposed via specialized APIs suitable for UI generation. Common API is for breadth when you need one code for all formats. Native API is for depth when you need native level control over one format. You choose what fits your task. Well, here we show a pseudocode on this slide. The entry point is intentionally minimal. A single call provides a database pointer, and from here, you are just one line of code away from accessing the model tree, properties, and geometry. The same code works for SolidWorks, Step, IGES. The SDK automatically detects the format and routes the appropriate native reader. It supports reading from traditional file passes or memory stream, which is critical for cloud-integrated application. For larger scale data, partial reading are supported, allowing you to load only the necessary segment of a file for a maximum performance. Next one. A separate highlight is support for the external 3DM format based on the OpenNURBS Rhino library, integrated into MCAD Common API. This is our first experience integrated a non-ODA format, and it has proven successful. The format works fully through the Common API, model hierarchy, object properties, geometry access, and visualization. We can confidentially say MCAD Common API is ready for virtually any MCAD mechanical CAD format. Now we are moving to a really small demo where we open the step file and show the different views we can see here, and we are manipulating via CAD Common API, and we can see different views, which views, and the files contain the PMI. PMI is also supported via Common API. Well, let's move to the next block. It's our SolidWorks support. Full native access to the SolidWorks provides SolidWorks SDK provides full native read and write access to SolidWorks parts, assemblies, and drawings. It's a production-ready library for data migration, custom viewers, and editing workflow. You can not only read, but also write back changes, update properties, relink assemblies, modify configurations, and save valid SolidWorks files. The key idea, you fully control the data layer on your own infrastructure. We support SolidWorks of 2011 up to 2025 in one API. All geometry is native Parasolid BREP and can be extracted directly. The SDK covers the full SolidWorks data stack across 10 core capability areas. First, we handle one foundational data layer. Our file input-output support all three primary documents type with stream-based processing for high performance. Beyond basic reading, you have deep access to configurations and the ability to perform operation on custom properties at every level. For structural data, the SDK enables complex assembly management, allowing you to traverse or link components dynamically. On the geometry side, we support Parasolid extraction and BREP conversion. This extends down the sketch entities, providing full support for everything from basic lines to complex polygons and splines. To support downstream engineering workflow, we include drawings and PMI. We also expose metadata such as version history and thumbnails. Finally, the architecture is built for growth. Through our extensibility layer, you can utilize plugin-based modules and custom resolvers to tailor the SDK to your specific workflow requirements. Well, beyond reading, the SDK gives full control over the assemblies. You can traverse and modify large structures, access components properties, and control configurations, display states, and suppression. We provide full transformation data, hierarchy info, and bomb flags for precise positioning. A key feature, programmatic relinking of component paths. Just update the path and write back. The system preserves structure, transformations, and validity. Works seamlessly across all SolidWorks versions and built-in validation. The SDK exposes rich annotation and manufacturing data. You can access full PMI, including geometric and text annotations, from simple lines to complex curves. The CDA tree in ODA Viewer provides a structured way to explore and link annotations directly to model geometry. For sheet metal workflows, we provide deep access to cut lists and properties, thickness, bend radius, K factor, materials, quantities, and dimensions. Everything's needed for downstream manufacturing and ERP integration. Now let's move to our next demo. It's a complex turbine assembly. And let's look at this live demonstration of our SDK handling a complex turbine assembly. As we navigate this 3D model, notice how the common data access tree or on the left instantly indexes every component's subassembly and individual bolt. By selecting a components like the rear casing, the system immediately exposes its metadata, including file paths, creation, dates, and unit systems directly from the underlying database. You can see here as we toggle components between resolved and suppressed to isolate specific internal geometry for inspection. Observe the click to select synchronization. Selecting a part in the 3D view highlights its corresponding entry in the hierarchy. Even within deeply nested subassemblies, the SDK maintains full at-4 transformation accuracy, ensuring every component is positioned precisely as intended in the original design. Well, let's looking ahead, our 2026 roadmap is focused on deepening visual fidelity and expanding cross-platform interoperability. We are introducing full API access and rendering for BREP entities that includes support for colors, textures, and materials, ensuring the output matches the original design intent. Future updates will include dedicated rendering for 2D drawings files and optional rendering of PMI symbols using the industry standard ASME Y14.5 font. To support high-performance graphics workflows, we are adding API access for tessellation mesh data. The next SDK is Interop SDK that provides native access to Autodesk Inventor files. Currently, it supports reading Inventor file formats from 2022 up to 2026 versions, both for parts and assemblies and for drawings. Public API allows you to extract ASIS 3D data from part files, get access to annotation, displays, lists, get access to standard and custom document properties. Visualization support is based on our ODA Visualize SDK. Support for assembly files is a complex feature. Assembly management includes a capability to traverse the assembly tree. On assembly tree. Using this straightforward API hierarchy, you can easily map the exact structure of complex Inventor assembly into your own user interface components, giving your users complete visibility into their engineering data. Well, now let's move to the next demo. It's in this video you can see the V10 engine for assembly file opened in the visualize viewer. This assembly file consists of part files and other assembly files. In our sample application, it's in our visualize viewer. You can see selection of different part, isolation of different parts, and all abilities that we provide to work with Inventor. Yeah, in our next sample application named Inventor Document Properties, you can see the list of properties including material and mass of the part, last saved by, last saved date properties of the file, and others. Well, our roadmap for this year for Inventor Interop includes support visualization for 2D IDW files, improvement in public API for annotations, visualization improvements, extending public API to traverse object collections and get properties, unified CAD API integration. Now let's move to the next block where we cover vendor governed open formats. Like the first one is Siemens GT. Lightweight visualization standards support the GT exchange format developed by Siemens. We provide visualization of both 3D and 2D geometry. Recent versions added support for selected PMI types and text rendering. GT files can be opened on our ODA viewer. A specialized GT viewer application based on Visualize SDK is also planned. In 2025, GT format version 10.6 was introduced. Support for this version is planned in future releases. Further improvements in text rendering and additional PMI visualization are also planned. Other two formats is a 3DM or open based on the OpenNorms library. A separate highlight is supported for this library, and it's integrated into our MCAD Common API. This is our first experience integrating of non-ODA format, and it has proven successful. ODA KIF SDK supports the KIF format. Currently implemented KIF reading, visualization of 2D and 3D geometry, text, PMI, access to assembly hierarchy, and view information via common data access interface. The SDK is production ready for reading. Creation and saving functionality still remains beta. Now we have a small demo application that illustrates GT visualization and PMI rendering for GT file. It's our debug application that uses our common Visualize SDK, and we see here both in 3D data and PMI from GT file. Well, the next block that we have is the block of open standards. And the main one is definitely STEP, the industry exchange standard. Over time, our ODA STEP SDK has evolved into a mature and well-proven library used by our customers in their own software products. During several years of development, we have implemented a feature set sufficient to support STEP in a wide range of practical scenarios. We continue to add new capabilities introduced into STEP through the activities of PDIS as we actively participate in CAC's implementers forum and closely follow all updates to the format. Our SDK supports all application protocol schemas, including AP 242, 214, including the recent 4 edition. We support all currently known geometric and topological entities defined in ISO standard and related standards. At member request, support for signature section was added, enabling generation and validation of digital signatures for STEP files. A separate highlight is PMI access through Common Data Access Interface, a feature appreciated by several customers. This enables visualization of PMI information. Semantic PMI data is provided directly as specialized symbols within strings, eliminating the need for additional interpretation on the client application side. Since this capability is not defined in ISO standard, it's provided as an optional STEP SDK feature. STEP SDK also allows retrieving associated geometric entities from their PMI objects and vice versa. This demo shows STEP visualization and PMI access. We provide visualization of product manufacturing information objects, including access to their semantic context and geometric dimension and tolerancing symbol, including on the top of ISO standard, as an additional capability for our users. Supplemental geometry is supported as well. Feature highlighting such as holes or fillets, annotation planes, ACES lines, etc. We provide access to the model, assembly object tree, and object properties through the CDI tree and CDI properties. Many capabilities of STEP SDK from the foundation for new tools and features in OpenStep Viewer, which is released in a monthly basis. Recent versions introduced usability improvements for our end-user product, enabling work with STEP files at multiple levels, both for developers implementing STEP support in their application and for end users performing direct analysis of STEP models. Well, I think now we can move to the further slides. And for the products, it's IGES. It's a quite stable format, solid implementation, and despite its age, the IGES neutral format continues to be used in major CAD systems, which is why we added IGES support. Since the format has remained unchanged for many years, the implementation is stable and does not involve IP evolution. ODA IGES SDK provides a set of classes representing IGES entities, including full read-write property access and business logic, including 2D and 3D visualization. IGES models can also be created from scratch and saved as IGES file, which is we actively use in IGES to DWG converter. A recent addition includes support for constructive solid geometry with Boolean operations and support for blocks insertions in the IGES form. Now we can move again to the demo small demo where we open IGES file in Open Step Viewer visualization of 2D and 3D geometry. IGES loading here is supported, and we can see the IGES data provided via common data access interface. Well, now we can move to the further. We plan to improve unified PMI conversion to STEP. We are also open to proposals for supporting additional formats, including external ones. GT version 10.6 support is planned along with improved PMI and text rendering. Well, what's coming this year? And Parasolid, CGM, and Granite are three different worlds with different mass, different tolerances, and different data models. In 2026, we are adding support for all three kernel ecosystems. This closes the last gaps in our format coverage. SolidWorks and Inventor are already shipping. CATIA, NX, and Creo are in active development, and plus the full set of open standards and vendor-governed formats. Well, now we move to CATIA, and is the Salt system flagship CAD system, version 5 and 6 product lines, and also powers 3D Experience platform. Internally, it uses CGM, a proprietary geomic kernel that has no public SDK or documentation. CGM is unique among kernels, fully proprietary with no external SDK, undocumented binary stream formats, proprietary file storage layer, and complex topology models supporting non-manifold geometry and multi-representation. And to support this, we split our work in different phases. The first one is completed with low-level storage and stream reading, stream position, validations. Now we are in progress on the phase 2, where we CGM object specs creation, geometry object reading, and topology model and web geometry access. And planned also phase 3 with tessellation, metadata extraction, and PMI reading. First beta targeted for the July of 2026. Next one is NX. Is Siemens CAD KI CAM system. It uses a unified PRT format for all model types, part assemblies, and drawings. The format is binary, proprietary, feature-based, and built on the Parasolid kernel. Parasolid is most widely licensed kernel in the industry, also used by SolidWorks, SolidEdge, and Onshape. NX uses a hybrid modeling approach, feature history plot, synchronous direct modeling. This means that feature tree coexists with direct edits, which adds complexity for readers. Our target capabilities are Parasolid native BREP reading, assembly traversal with constraints and transforms, PMI extraction, visualization, and CDI integration. And the next one, and the last for plan for this year, is Creo. Creo is PTC's parametric CAD system. It uses proprietary binary format, PRT for parts, SM for assemblies, DRW for drawings. Creo is built on the Granite kernel, PTC's own geometric engine. Unlike Parasolid, Granite is not a separate product. It's fully integrated into Creo and oriented toward feature regeneration, tolerance-based modeling, and geometry healing. Our target capabilities are Granite geometry reading, feature tree and parametric data access, assembly hierarchy traversal, PMI extraction, visualization, and CDA integration. And next slide show us a timeline table for quarterly breakdown of CATIA, NX, and Creo development milestones. So you can see that on this slide. Well, by the end of 2026, ODA MCAD will be the platform providing native access to all major MCAD systems. SolidWorks and Inventor already shipping, CATIA, NX, and Creo coming this year, plus the complete set of open standards, STEP, IGES, GT, KIF, 3DM. The architectural foundation unified API of a native BREP for all formats, vendor neutral, no intermediate conversion, consistent cross-format data model. This is not a viewer and not a converter. This is open infrastructure for any application that needs MCAD data. And it leads us to cross-format pipelines, convert what our member needs. One of the key advantages of unified mechanical format approach is unified conversion to STEP, the de facto MCAD exchange standard. Any common API supported format can be converted to STEP in just a few lines of code. This is an universal pipeline that works automatically for any format that complies with common API design rules. Interestingly, while adding 3DM support, we did not explicitly plan step conversion. Compliance with common API design rules automatically enables it. This was validated in practice. In addition to the universal pipeline, we provide bidirectional conversion between STEP and DWG and conversion from IGES and DWG. Well, development of STEP DWG interoperability continues. We constantly receive improvements requests from users regarding bidirectional conversion quality, and we respond to them promptly. We support conversion of both 2D and 3D geometry, including boundary representation in both directions. PMI conversion is supported, however, when converting 2D WG, only the geometric representation of PMI is transferred, not the semantic data yet. Additionally, view definitions from DWG can be imported from STEP for further use in supporting application. Recent releases include numerous fixes as well as conversion process logging, allowing users to immediately evaluate results during conversions. And also we implemented the IGES DWG bridge. It includes a DWG to IGES conversion modules. Supported entities includes 2D and 3D objects, partial PMI and dimensions, text, blocks, hatchings. IGES models can also be created from scratch and saved as IGES model. And now we switch to a short demo. You see that all those formats that we opened with a common CAD API, and this using of common CAD API allows us to use the same approach for step conversion of all these formats, GT, SolidWorks, CATIA, and others, and provide converting to the step in universal, in the same manner, through the same API. Yeah, now we see opening of all these files in the OpenStep viewer. So all those formats were converted in the step via the same single universal interface. I hope it simplifies life of developers. And again, I need to highlight that we talk about the API, not about the common intermediate format. The data are still in their own databases. Well, let's move to the question, why ODA MCAD? To summarize, our platform stands on three core pillars. Breadth, all major formats, proprietary and open in one platform. With CATIA, NX, and Creo, the coverage is complete. Depth, not a viewer, full native BREP and PMI for real manufacturing workflows. Unity, one common API across all formats. Same code everywhere. And when needed, format-specific APIs give you full access to native features. One platform, two levels. You choose the depth. Highlight for roadmap of this year. In second quarter of this year, we are going to provide CATIA beta, API extension for Inventor support. In third quarter, SolidWorks BIM integration, GT 10.6, and NX and Creo will be in progress. And by the end of this year, we are going to provide support for NX and Creo and CATIA production support. Ongoing work is OpenStep pure monthly releases, conversion quality improvements, and we plan to further improve unified PMI conversion to the step. We are also open to proposals for supporting additional formats, including external ones. So we are moving to the end of our presentation. So feel free to set up a personal meeting with our team to dive deeper or discuss your specific MCAD use cases. Thank you for your attention. Now we can move to the question and answer session. So, we see a number of questions now, and I would start from the first one. Is it possible to read CATIA version 5 files, formats for parts, products, and drawings? And I think, Peter, you...
Yeah, it's my plate.
Yeah.
So, to answer this question in short form, yes, we will. At first release, we are focused on reading graphic and present visibility for user. And as a result, CAD part files will be delivered as first part of our SDK, and all Inava will be available later. That's it.
Okay. Yeah, thank you. The next one I see this using Core SDK and plus MCAD extension, can you build an application to read and visualize step files? Igor, probably you can provide some details about that.
Yeah. Hello, everyone. Of course, yes. Several minutes ago, you have seen an examples. So step format is one of MCAD unified API supported formats, so such application can be built. And more to say, we have a good example applications for working with step and other formats as part of our release archives. And in addition, ODA Visualize SDK-based module for conversion of step and other formats into Visualize SDK. So the answer is yes.
Great. Taking into account, the next question seems to be also for you. Is it possible to visualize step files on the web with HTML and JavaScript?
And actually, currently there's no direct conversion into standalone format compatible with HTML or JSON without any additions, but probably Yuri will add some more information about Visualize SDK and MCAD formats.
Yeah, does Visualize, yeah, we have another quite similar questions about does Visualize JS support all CAD formats? And
Yes. I have already contacted with corresponding team in ODS SDK, and at this moment, this feature is not supported in ODS SDK. But at the same time, the corresponding development team had previously planned to expand Visualize.js support to include all MCAD format in second half of 2026 years. This task is planned on this year.
right.
So.
Well, and I see one more question. It's maybe not directly, okay, at least from the format set, it doesn't directly relate to the MCAD, but are you planning to add support for E57 point cloud files in the Visualize SDK? It's not directly to MCAD, but Yakov, maybe you can provide some answer for that as we.
Everyone, and the short answer is yes, we want to add such support in the future. However, this functionality, as it was mentioned, is related to our other project, Scan2Beam. Further information about our plans for Scan2Beam will be provided in a subsequent webinar in the DevConnect series. Currently, users can independently import point clouds from E57 format to RCS format, which is the base format for point cloud visualization in the ODA Visualize SDK. For this purpose, user may use the corresponding import API provided by our point cloud SDK.
Great. Thank you, Yakov. Overall, it seems to be that's it, what I see in our list. And yeah, well, in that case, we can wrap up our webinar. Also, again, very welcome. Feel free to set up a personal meeting. We'll talk and we'll provide any details about MCAD, about product. So we have this conversation, so we'll be happy to discuss. So thank you all for your attention. Yes, and bye.